Hello guys, welcome to another video here on the pre-security learning part, and today we're covering the last room for the Linux Fundamentals module, which is Linux Fundamentals part 3. And without further ado, let's start. The first thing here on the Linux Fundamentals part 3 is a walkthrough video. We're skipping that and we're heading straight to task 1. Now, welcome to part 3 and the finale of the Linux Fundamentals module. So far, throughout the series, you've got hands-on with some fundamental concepts and used some important commands. Now, this room is going to showcase some useful utilities and applications that you can likely to use day to day. Okay, you are also going to advance your Linux full skills by learning about automation, package management, and service application logging. Okay, now without further ado, let's proceed. Okay, that concludes task 1. Heading straight to task 2. Deploying your Linux machine. We're going to just start this machine quickly. Press the green button to start the machine button on the top right side of the task, and then scroll to the top of the page to see the deployment. I'll just go straight to start the box while it loads. And okay, quickly, you have the IP address displayed in the address of your Linux machine that you'll be logging into using SSH. Take note of this for now. We're going to do that later once we have our IP address in 32 seconds. Okay, now Now deploying the Tryhackme attack box. Looking at the top of the page, press the start attack box. We've done that button to display the Tryhackme attack box that we'll be interacting with. The Tryhackme attack box is a Ubuntu Linux machine that is hosted online in the cloud and can be interacted with via your browser. Now you will be using this to interact with the machine that you deploy in the task. Okay, we're waiting for this to load up. Now, using the following credentials: IP address. Okay, I think my IP address is ready now. Username Tryhackme, password Tryhackme, using the secure shell login. I've logged into the Linux Fundamentals part 3 machine using SSH, and I've deployed the attack box successfully. I'm waiting for this to load. 53%. Come on. Okay, our IP address here is ready. 10.10.97.31. 10.10.10.97.31. Waiting for the box to load. It's taking time. What's here on task 3? Okay, straight hands on deck opportunities. Let's kindly wait. I might fast forward this part or just don't want to fast forward it. Now let's just go ahead and complete it while I wait for it to load. Once it's done loading, I'm just going to log into it. Okay, let's go straight to task 3. I'll log into this as soon as we're ready for it. Okay, now throughout the series so far, we have only stored texts in files using a combination of the echo command, of course, and the pipe operators. Okay, this is the pipe operators, and this isn't an efficient way to handle data when you're working with files with multiple lines and the sorts. Okay, now introducing terminal text editors. There are a few options that you can use, all with a variety of friendliness and utility. This task is going to introduce you to Nano, but also show you an alternative named Vim, which Tryhackme has a room dedicated to for Vim. Okay, Nano. Before we get into that, let's now quickly log into machine here. Okay, and let's go straight to this. Open that up, and we have SSH, and we have Tryhackme at 10.10.97.31. Let me quickly confirm that, please. 97.31. Okay, great. And once you do that, it's going to ask us if we sure we want to continue. Yes, and the password is Tryhackme. Note it's been typed but it's not showing, and Tryhackme password inserted, and we are live. Okay, we are in. Now let's go on. Now we're here, so introducing terminal text editors. So we're going to be working with Nano and then alternative Vim. Let's head on to Nano. It is easy to get started with Nano. To create or edit a file using Nano, we simply use Nano file name, replacing file name with the name of the file you wish to edit. Okay, it's more like an editing tool. So Nano, example here, introducing Nano, my file. It will boot up this particular information here, and then some couple of options on how to actually just operate, read, replace, and redo, and so on and so forth. Now, once we press enter to execute the command nano, nano will launch, where we can just begin to start entering or modifying our text. Now, you can navigate each line using the up or down arrow keys to start a new line. Okay, let's see, up and down arrow keys, or start a new line using the enter key on the keyboard. Okay, now we have this let's say you've modified yellow Tryhackme. I can write things into my file. Once you're done, Nano has a few features that are easy to remember and covers the most general things you want out of the text editor, including searching for text, copying and pasting, jumping to a line number, finding out what line number you are on. Okay, you can use these features of Nano by pressing the Control key, which is represented as the up key. So Control is this up arrow or something on Linux, and the corresponding letter. For example, to exit, we will want to press Control X to exit Nano. Okay, now heading straight to Vim. Do we practicalize? Let me just Control L. And do we have any file here? We have tax tree. Okay, let's just go straight. We're going to practicalize later. Let's just say I create a file, and that should be echo me. I want to echo it into let's see, echo it into me, and enter, and then ls. I have that me there, so I just want to nano me, that is edit me, enter. I can see the nano there, so I'm just going to use the arrow to move, and then new line. I'm just going to say this is the edited version, or let's say edited version. And with that, I can use, if you come over to the bottom here, get help, exit, write, save, read file. Where's the save? How do we save? Paste, test, replace. How do we save? It doesn't show everything. You know what? Okay, if I just press Ctrl X, it will ask me if I want to save. I guess yes, I want to save. Why? And file name to write me, yes, enter, and it saved it. So if I say if I cut me, I should be able to see the edited version. Great. So let's go to Vim. Now, Vim is a much more advanced text editor. Whilst you are not expected to know all advanced features, it is helpful to mention it is for powering up your Linux queue. Okay, let's see. Now, some of Vim's benefits, albeit taking a much longer time to become familiar with, includes customizable. You can modify the keyboard shortcuts to be of your choosing. Wow. Syntax highlighting. This is useful if you are writing or maintaining code, making it a popular choice for software developers. I think I would like to learn that later. Vim works on all terminals where Nano may not be installed. There are a lot of resources such as cheat sheets, tutorials, and all sorts available to you to use. I guess available to you use. Okay. Tryhackme has a room showcasing Vim if you're wishing to learn more about this editor. Okay, now create a file using Nano. I've done that. Edit tax 3 located in Tryhackme's home directly using Nano. What is the file? So let's just go Nano. Let's go to the terminal here. List again. You should see that there's tax 3 here. So I just want to Nano, and once I start typing task, use the tab button, is complete, enter, and you're here. So this is actually the flag here, so I don't need to edit this any much long. It's just the flag that we need, enter, and then I come over here to exit, Ctrl X, and we're done. Straight up to tax 4. All right, on tax 4 here we have let's see, it's okay, tax 4, general / useful utilities. Now, downloading files using wget. Okay. Now, a pretty fundamental feature of computing is the ability to transfer files. Now, for example, you may want to download a program, a script, or even a picture. Thankfully for us, there are multiple ways in which we can retrieve these files. Now, we are going to cover the use of wget. This command allows us to download files from the web via HTTP as if you were accessing the file in your browser. Makes sense. Now we simply need to provide the address of the resource that we wish to download. For example, if I want to download a file named myfile.txt or .txt onto my machine, assuming I knew the web address, it would look something like this: wget http. This is like the URL link to the particular myfile.txt link. Okay. Now, transferring files from your host, that's for wget, right? Now, transferring files from your host, SCP, or in bracket SSH. Now, secure copy is this SCP. Secure copy or SCP is just a means of securing copying files, okay? Unlike the regular CP command, this command allows you to transfer files between two computers using the SSH protocol, okay, to provide both authentication and encryption. Now, working on a model of source and destination, SCP allows you to copy files and directory from your current system to a remote system, copying files and directory from a remote system to your current system. Makes sense. Now, provided that we know usernames and password for a user on your current system and a user on the remote system, for example, let's copy an example file from our machine to a remote machine, which I have neatly laid out in the table below. Now, variable: the IP address of the remote system is 192.168.1.30. The user on the remote system is Ubuntu. Name of the file on the local system, important.txt. Name that we wish to store the file on as the remote system is transferred.txt. Now, with this information, let's craft our SCP command, remembering that the format of SCP is just source and destination. Okay, now we have SCP important.txt Ubuntu. Ubuntu is the other machine. That is the user on the remote machine at 192.168.1.30, which is the IP address of the remote machine, and then the particular source of that particular file that we want to save it on the current machine, on the remote machine. Yes, because we're actually copying everything from the local system. So now this is the name of the file on the remote system that we, after being copied, or when it's successfully copied. Okay. Now let's reverse this and lay out the syntax for you using SCP to copy a file from a remote computer that we are logged into. Now, the IP address of the remote system is this, the user on the remote system is this, name of the files on the remote system is this, and the name that we wish to store the file on our system is node.txt. So in this case, it will now be SCP Ubuntu. We are locating where the remote file is, and this is what we want to copy it to. So in this case, it's important that when we are actually copying the file from when we are copying the file from our local system to a remote system, we'll start with the file here, and then when we are copying from the remote system, when we're copying from the local system to a remote system, we start with the file, of course, and then when we're copying from the remote system to our file or to our local system, we'll start with the location of the remote system and then the name of the file we want to copy it into. Okay, makes sense. Now, serving files from your host, which is web. Okay, now we have Ubuntu machines come pre-packaged with Python 3. Now, Python helpfully provides a lightweight and easy to use module called HTTP server. Now, this module turns your computer into a quick and easy web server that you can use to serve your own files, where they can then be downloaded by another computer using commands such as call or wget. Now, Python 3's HTTP server will serve the files in the directory where you run the command, but this can be changed by providing options that can be found within the manual pages. Okay, now simply all we need to do is to run python 3-m http.server in the terminal to start the module. In the snippet below, we are serving from a directory called web server, okay, which has a single name file. Now we have server python 3m.http. This is how we start it, and then now let's use wget to download using the 10.10.97 address and name the file. Remember, because the Python 3 server is running port 8000, you will need to specify this within your wget command. For example, wget this particular slash, you have to indicate the port, then slash my file. Note you will need to open a new terminal to use wget and leave the one that you have started the Python 3 web server in. This is because once you start the Python 3 web server, it will run in that terminal until you cancel it. Okay, now let's take a look into the snippet below as an example. So we type in the wget file, connected, completed saving file, 100% saved. Now remember, you will need to run the wget command in another terminal while keeping the terminal that is running Python 3 server active. An example of this on the Tryhackme attack box is below. This and two. So you just open two commands. One will be running the server, and then you'll be copying on the second one. Okay. One flaw with this model is that you have no way of indexing, so you must know the exact name and location of the file that you wish to use. This is why I prefer to use the updog. What's updog? A more advanced yet lightweight web server, but for now let's stick to using Python's HTTP server. Ensure you are connected to the deploy instance 10.10.97.31. we already done that. Now use the Python 3 HTTP server module to start a web server in the home directory of Tryhackme. Let me see if I have an option to open another terminal to the downside. Let's see. Okay, I'm going to bring this to the downside a little bit. That will be hard though. Okay, let's put this one short. Okay, so let me put this on the top here. All right. No, that's not what I asked you to do. Okay, let's quickly start. Let me see. Control L, and here we're just going to start what's the Python 3 server. Let me see. I'm just going to copy it exactly the way it is. No, that's not how to start the terminal. The terminal is Python 3 -m HTTP server, and there we go. Okay, I can copy directly until I have pasted here. Okay, and here we go. Sorry, let's see. Okay, already copied. It's already on that. Ctrl V. Cause why? Ctrl Shift V. All right, enter. So we're running this right now here, and then let's head on to this next task here. This new task box here. We're going to run the copy of our file. Let's just say I've done that second one. It's running right here now. Now use Python 3 HTTP server module to start a web server in the home directory of the Tryhackme. We've done that. Okay, now download this particular flag test on the Tryhackme attack box. Remember, you will need to do this in a new terminal. Okay, all right. Let's see. Let me paste the one I copied before, and let me paste here. Ctrl Shift V. Okay, and let's see if I have anything. All right, so it's the same. I just need to change the file name, which is .flag.txt. Enter. It's downloading. I think we're done downloading that. What are the contents? So let's say ls. Let me see if I've downloaded. Where's the downloaded file? I copied. Where did it download to? I think in my files. Come in. Why? Flag.txt 200. It was successful. Okay, it can't show because it has a dot file. It has a period. So ls dot. Let's view everything here. So we can actually see that it's here. Where is it? Yeah, flag.txt. Okay. All right. To view that, let me see if I can just go on a cat. Okay. Hold on. Come on. And let me just put this up a little bit. Alright, so let's just cat dot flag dot txt. Let me see if it completes it. That, boom, and there we have it. There we have the flag right here. Okay, and there we go. Create and download files to further apply your learning. See how you can read the documentation on Python 3 HTTP servers model. Use Ctrl+C to stop the Python 3 HTTP server once you're finished. I'm done, so just use Ctrl+C, right? Ctrl plus capital letter C. Let's put Ctrl+C, and there we go. We stopped it. So Ctrl+L, and that ends that part. So completed. So we are done here with task 4, and we'll continue with task 5. Okay, so task 5, processes 101. All right, so I had to just take a while to just make sure I charge up my computer. So now, processes are the programs that are running on your machine. Now, they are managed by the kernel, where each process will have an ID associated with it, also known as its PID. The PID increments for the order in which the process starts, or the process starts. That is, the 60th process will have a PID of 60. Now, viewing process, we can use the friendly ps command to provide a list of the running processes as our user section and some additional information such as its status code. Now, the session that is running it and how much usage time of the CPU it is using, and the name of the actual program or command that is being executed. So on the cmnatics here, you type ps, it will just list out everything, the processes that is running here. If you do it again, it will change. Okay, let's see what happens. Now, note how in the screenshot above, the second process PS had a PID of 204, and then in the command below, in the command below, then this is then incremented to 205 when you did it again. Now, to see the processes run by other users and those that don't run from a section, that is system processes, we need to provide aux to the ps command, like so, px aux. They'll be able to see everything. Okay, now note, we can see a total of 5 processes here. All right, note how we now have root and cmnatics. Okay, now another very useful command is the top command. Top gives you real-time statistics about the processes running on your system instead of a one-time view. These statistics will refresh every 10 seconds, but will also refresh when you use the arrow keys to browse the various rows. Another great command to gain insight into your system is via the top command. Okay, once you type in top, I believe, and it should give you everything. Yeah. Let's just quickly do that here on this system. So you type top and enter. Okay, not on capital letter. Top. Why am I having this on tab? Okay, top, and that should do it. So basically giving us everything here on the command. Okay, managing processes. You can send signals that terminate processes. There are a variety of types of signals that correlate to exactly how cleanly the process is dealt with by the kernel. To kill a command, we can use the appropriate we can use the appropriately named kill command and the associated PID that we wish to kill. That is kill PID 1337. We would use kill 1337. Okay. Now below are some of how can I end this? I think Control Z. I should end it. Yeah, that's it. Okay. Now below are some of the signals that we can send to a process when it's killed. Seek term, kill the process, but allow it to do some cleanup tasks beforehand. Seek kill the process, doesn't do any cleanup after the fact. Seek stop or suspend the process. Now, how do processes start? Let's start off by talking about namespaces. The operating system OS uses a namespaces to ultimately split up the resources available on the computer to processes such as CPU, RAM, and priority processes. Okay, and think of it as splitting your computer up into slices, similar to a cake. Processes within that slice will have access to a certain amount of computing power. However, it will be a small portion of what is actually available to every process after all. Alright, overall, alright, now namespaces are great for security, as it is a way of isolating processes from another. Only those that are in the same namespace will be able to see each other. Now, we previously talked about how PID works, and this is where it comes to play. The process with an ID of 0 is a process that is started when the system boots. Now, the process is the system's init on Ubuntu, such as systemd, which is used to provide a way of managing a user's processes and sits in between the operating system and the user. For example, once a system boots and it initiates, systemd is one of the first processes that are started. Any program or piece of software that we want to start will start as what's known as the child process of systemd. Now, this means that it is controlled by systemd. It's controlled by systemd. Now, but will run as its own process, although sharing the resources from systemd. Makes sense, to make it easier for us to identify and likes. Okay, so the first thing here, PID1 is systemd. So you can see here, over here, root, and we have here systemd. Great. Now, getting processes or services to start on boot. Now, some applications can be started on the boot of the system that we own. For example, web servers, database servers, or file transfer servers. This software is often critical and is often told to start during the boot up of the system by administrators. Now, in this example, we are going to be telling the Aperture web server to be starting Apache manually and then telling the system to launch Apache 2 on boot. Sorry. Now, enter the use of systemctl. This command allows us to interact with the systemd process daemon. Continuing on with our example, systemctl is an easy to use command that takes the following formatting: systemctl option service. Now, for example, to tell Apache to start up, we will use systemctl start Apache 2. Seems simple enough, right? Same with if we want to stop Apache, we will just replace the option with stop instead of start like we provided. We can do 4 options with systemctl: start, stop, enable, disable. Okay. All right. Now, an introduction to backgrounding and foregrounding in Linux. Processes can run in 2 states. In the background and in the foreground. For example, commands that you run in your terminal, such as echo or things of that sort, will run in the foreground of your terminal, as it is the only command provided that hasn't been told to run in the background. Now, echo is a great example, as the output of echo will return to you in the foreground, but wouldn't in the background. Take the screenshot below, for example. So, echo hi thm, echo hi thm, and just and. Okay, let me see. Now here we are running echo hi Tryhackme or thm, where we expect the output to be returned to us like it is at the start. But after adding the AND operator to the command, we are instead just giving the ID of the echo process rather than the actual output, which is what we saw here, 16889. Okay, as it's running in the background. Okay, makes sense. Now, this is great for commands such as copying files, because it means that we can run the command in the background and continue on whatever further commands we wish to execute without having to wait for the file copy to finish first. Now, we can do the exact same when executing things like scripts. Rather than relying on the AND operator, we can use Ctrl+Z on our keyboard to background the process. It is also an effective way of pausing the execution of a script or command, like in the example below. So while it's running, we just do Ctrl+Z and it stopped. I did that here just to stop the processes when it was just running, when I used top. Now, the script will keep on repeating. This will keep on looping until I stop. Okay, it will keep on repeating. This will loop on this will keep on looping until I stop, which is what is here, until I stop or suspend the process by using Ctrl Z as indicated by T raised to power Z. Now our terminal is no longer filled up with messages until we foreground it, which we will discuss below. Okay, now foregrounding a process. Okay, now that we have a process running in the background, for example our script background.sh, which can be confirmed by using ps-aus, a command, we can backpedal and bring the process back to the foreground to interact with it. Okay, as you can see, this is running on the foreground, in the background. Now let's see, with our process backgrounded using either Ctrl+Z or the AND operator, we can use FG to bring this back to focus like below, where we can see the FG command is being used to bring the background, process back into use on the terminal, where the output of the script is now returned to us. So if I just type FG and it becomes back, let me see if I do this FG, enter. Wow, okay, makes sense. Ctrl Z, stops again. Great. All right, readme, we've done that. Answering the questions, right? We'll readme, we've done that. Now if we were to launch a process where this previous ID was 300, what would the ID of this new process be? It would be 301, an increment of 1. Correct. Now if we wanted to cleanly kill a process, what signal should we send it to? It should be sig kill. No, not sig kill. Sig stop. Let's see. Sig stop. Cleanly. What's cleanly there? It should be sig stop. No, sig stop is suspend. Sig kill to kill the process, doesn't do any cleanup. Okay, cleanly. Then that should be sig term. All right. Okay. Sig term. Now locate the process that is running on the deployed instance 10.10.97.31. What is the flag? Should I just use, let me use px aux and see something. Ps aux, let's see what should locate the process. Let me see. Ps aux, what do I have? Tryhackme plus, let me see, that's the last thing I just did. What are we locating? What exactly are we asked to locate? There's a lot of things running right here. Okay, you say locate the process that is running on the deployed system instance. What is the flag given? Oh, I see. What's this? Okay, let me put this here and let's see. Let me go to the end here and ps aux. I did that previously, right? And this is it. So which one looks out of the ordinary? What looks okay? THM processes. This looks out of it. Okay, I've seen it. Okay. All right. Then what command would we use to stop the service? My service. To stop it, we should use. Let me get the hint here. It says system. Oh, okay. System CTL. Option, then the service. Okay, to stop a service, if you need to use system CTL, and that should be the option is to stop, and the service is my service. System CTL. Okay, what command would we use to start the same service to boot up on our system? Reboot. It should be reboot. No, it should be boot. Forgetting the second option right there. Let's quickly take a look at it. Looks like I didn't really grab that. System CTO processes, getting process. System CTO, we have enable, so enable or disable. Okay. All right, what command would we use to bring previously background processes back to the foreground? That's simple. FG, and that ends us with task 5. Straight up to task 6. Task 6 here says maintaining your system automation. Now, users may want to schedule a certain action or task to take place after the system has been booted or has booted. Now, take for example running commands, backing up files, or launching your favorite programs on such as Spotify or Google Chrome. We are going to be talking about the cron process, but more specifically how we can interact with it via the use of cron tabs. Now, cron tab is one of the processes that is started during boot, which is responsible for facilitating and managing cron jobs. Okay, here's like checking out for cron. Okay, let's see. A cron tab is simply a special file with formatting that is recognized by the cron process to execute each line step by step. Cron tabs require 6 specific values. Now, the value first is min, what minute to execute at. Hour, what hour to execute at. DOM, which is like the day of the month, what day of the month to execute at. MON, what month of the year to execute at. D of W, what day of the week to execute at. And CMD, which is the actual command that will be executed. Wait. Now, let's use the example of backing up files. You may wish to back up CMNATIX documents every 12 hours. We would use the following formatting, which is like this: CP-R home synaptic document VAR. So what's this? This is more like showing. Okay, an interesting feature of cron tab is that these also support the wildcard or asterisk. Okay, if we do not wish to provide a value for a specific field, that is, we don't care what month, day, or year is executed, only that it is executed every 12 hours, we will simply just place an asterisk. So the seconds, every seconds of the day. Do we have every seconds of the day? Every minute of the day. So there's no minutes, just the hours, and the rest we keep it to asterisk. So we didn't specify the minutes, we specify the hours, we didn't specify the DOM, the MON, and the DOW. Okay, great. Now this can be confusing to begin with, which is why there are some great resources such as the online cron tab generator that allows you to use a friendly application to generate your formatting for you, as well as the site Cron Guru. Okay, now cron tabs can be edited by using cron tab-e, where you can select an editor such as Nano to edit your cron tab. Okay, all right, makes sense. Okay, all right, let's answer the question. Ensure you are connected to the deployed instance and looking at the running cron tabs. Let me just run cron tab. Let me run cron tab -e and see. Aha! Okay, I see what happened. I see what I'm supposed to do. So when I do that, I'm supposed to edit. Okay, ensure that you're connected to the deployed instance and looking at the running tab. What am I supposed to do? Though I've completed that one. When will the cron tab on the deployed instance 10.10.97.0 run? When? Okay, let me just go back to that cron tab and I think the answer is there. I'm just doing too much, I believe. Let me run this back, and I have, this was me editing this. It's supposed to, when is it supposed to release? Every 5 a.m. When is it supposed to run? For example, you can run the backup tab. No, this is an example. For more information on the manual, see cron tab 5 for cron tab 8. What am I supposed to complete here? I'm just going to post this video this way. This is how studying sometimes with no video. Let me see. There's a walkthrough video here, right? Let me see. I'll just quickly do this in my Google. Okay, the crazy thing is I was looking at the answer right in front of me. At reboot is actually the answer. Now this is like a special instance, and that goes it. So all right, I see. Now task 7. Let's head on to straight to task 7, maintaining your system package management. Okay, let me just exit this place. Okay, now introducing packages and software repos. When developers wish to submit software to the community, they will submit it to an apt repository. If approved, their programs and tools will be released into the wild. Two of the most redeeming features of the Linux shine to light here: user accessibility and the merit of open source tools. Okay, now when using the ls command on Ubuntu 20.04 Linux machine, there are files. These files serve as a gateway registry. Okay, Ubuntu ls and so on and so forth. Okay, repository. Okay, while operating system vendors will maintain their own repositories, you can also add community repositories to your list. This allows you to extend the capability of your OS. Additional repositories can be added by using the add apt repositories command, or by listing another provider. For example, some vendors will have a repository that is closer to their geographical location. Managing your repositories, adding and removing. Now, normally we use the apt command to install software onto our Ubuntu system. Now, the apt command is a part of the package management software, also named apt. Apt contains a whole suite of tools that allows us to manage the packages and sources of our software and to install or remove softwares at the same time. Now, one method of adding repositories is to use the add-apt.repository command we illustrated above, but we are going to walk through adding and removing a repository manually. While you can install software through the use of package installers such as dpkg, the benefits of apt means that whenever we update our system, the repository that contains the pieces of software that we add also gets checked for updates. Now, in this example, we are going to add the text edit Sublime. We're going to add the text editor Sublime Text to our Ubuntu machine as a repository, as it is not a part of the default Ubuntu repositories. Okay, now when adding softwares, the integrity of what we download is guaranteed by the use of what is called GPU, the GNU Privacy Guard keys. Now, these keys are essentially a safety check from the developers saying, here's our software. And now, if the keys do not match up to what your system trusts and what the developers used, then the software will not be downloaded. So to start, we need to add the GPU key for the developers of Sublime Text 3. Now, note that Tryhackme instances do not have internet access, and so we are not expecting you to add this to the machine that you deploy, as it would fail. Now, let's download the GPG keys and use apt-key to trust it. Now, you get it. Okay. Now that we have added this key to our trusted list, we can now add Sublime Text 3 repository to our app sources list. A good practice is to have a separate file for every different community/third-party repository that we add. Now, 2.1, let's create a file named sublimetext.list in this location and enter the repository information like so. Once you do that, now 2.2, and now use Nano or text editor of your choice to add and save Sublime Text 3 repository into this newly created file. Okay. Now, after we have added this entry, we need to update apt to recognize this new entry. This is done using the apt update command. Once successfully updated, we can now proceed to install the software that we have trusted and added to apt using the apt install Sublime Text. And then removing packages is as easy as reversing. Now, this process is done by using the add-apt-repository -remove and the file name of ppa something like that. Now, this command, or by manually deleting the file that we previously added to. Once removed, we can just use apt remove software's name, that is apt remove sublime.txt. Okay, Answer the question below. Since Tryhackme instances do not have internet connection, this task only requires you to read through the material. We've done that, and let's head on to task 8. Over here on task 8, we're going to be treating maintaining your system. We're looking at logs. Now, we briefly touched upon log files and where they can be found in Linus Fundamentals Part 1. I remember. However, let's quickly recap. Now, this is located in the var/log directory. These files and folders contain login information for applications and services running on your system. Now, the operating system OS has become pretty good at automatically managing these logs in a process that is known as rotating. Now, I've highlighted some logs from 3 services running on Ubuntu machine and Apache 2 web server. Logs for the failed to ban service, which is used to monitor attempted brute force, for example, the UFW service. For example, now the third is the UFW service, which is used as a firewall. Okay, the first one is Apache 2. This is one of the highlighted 3 services running Ubuntu. The failed to ban log, this is attempted brute force, and the UFW, which is the acting as a firewall. Okay, now these services and logs are a great way in monitoring the health of your system and protecting it. Not only that, but the logs for services such as web server contain information about every single request. Now, allowing developers or administrators to diagnose performance issues or investigate an intruder's activity. For example, the 2 types of log files below are of interest: access log and error log. Alright, I see. I saw access log one time. Now, there are of course logs that store information about the OS, about how the OS is running itself, and actions that are performed by users, such as authentication attempts. Now, look for the Apache 2 logs on the deployed Linux machine. Let's check the hints first before I go on. Located in the VA. Okay, let's just Ctrl L and ls-la. Let me see everything. So here we have .var. I can't see it here. Okay, the set is located. Let me see cd/var. Let me hit the tab and see var. Location here is -log.apache. I'm supposed to see this here though. Log. Let's see. Apache. Okay, let me see if I can locate that. cd.apache 2. Let me see if I go into there. Enter. No. 2. Enter. Okay, list. Okay, now we have now we have access log 1. So what are we looking out for? We've done that. What is the IP address of the user who visited the website? So let's look at access log. Cat access. Let me see. Cat access log. Let me see that. Okay. Permission denied. So can I use sudo cat access the log? It should be Tryhackme. No. Okay, let me use access.log1. I think that's why it's highlighted. So let me just use cat access.log.1 and see if I can access that one. Okay, looks like I do have an access here. We have someone accessing the system here, and blah blah. So, what is the IP address? Do you have any IP address here? Yes, 10.2.2.11. To copy this, and let's see. Is that the answer? Great. Now, what file did they access? They accessed what file? What file did they access here? I might have to go into I already cut this particular one. So what they accessed a /cat.sandbox.jpg. So that is what. And let me see. Great, amazing. Wow, this particular room took a toll on me. Now, task 9, conclusions and summaries. Welcome to the end of Linux Fundamentals module. Your familiarity with Linux will improve as you get to interact with it over time. Now, Linux has the potential to do very powerful things with relative ease, as you have hopefully discovered throughout this module. That's true. Now, to recap, this room introduced you to the following topics using the terminal text editors like Nano, like Vim, general utilities such as downloading and saving context using a Python web server like w.get to download, a look into processes, the PID and the top, maintaining and automating your system by the use of crontal, package management, and reviewing logs. Okay, now continue your learning in some other Tryhackme rooms that are dedicated to Linux tools or utilities. We have batch scripting, yes, regular expressions. Okay, and now terminate the machine deployed in this room from task 2. We terminated that room, terminated the machine, and then continue your learning in other Linux dedicated rooms. And that is the end of it. Thank you so much for learning with me. This concludes the Linux Fundamentals. Next, we'll be going into Windows Fundamentals. This part 3 was actually, but I learned a lot. Thank you also. Thank you for learning with me. And let me say that again. And see you guys in the next video, and enjoy your day. Ciao.